In this video lecture, we're going to discuss epsilon NFA to NFA. So let's consider this example. We have three states. A is the initial state, C is the final state, B is a non-final state. And between A and B, we have an epsilon transition. Between B and C, we also have an epsilon transition. So in case we want to remove epsilon, okay, in our NFA to to create an ordinary NFA. Okay, so we're going to check all possible paths. Okay, in considering all inputs, so that we could remove the epsilon. Okay, in doing that, so we're going to check each state. So each state determine the epsilon enclosure. If say epsilon closure, all state that could be reached through epsilon and itself. So for example, A, its epsilon closure will be itself, 1. We have an epsilon transition going to B, so B will be part of the closure. And A could reach C through this 2 epsilon transition. So therefore, C is part of epsilon closure for A. So A could reach A, B, C through epsilon. Okay, so that's the meaning of epsilon closure. After determining the different state that could be reached by a certain state from a certain state, we're going to consider the input, the alphabet. Okay, so the input or alphabet will determine the next hop or the next state. Okay, and this next state, there is a possibility that it is connected to another E transition. So that's why we're going to check again the epsilon closure of the next state. That will be the final state or the final path for the state that we are analyzing. Okay, so again, epsilon closure means all the state that can be reached from a particular state only by seeing the epsilon symbol. Okay, and we need to fill this up, this table, this transition table, so that we could convert this NFA or epsilon NFA to an ordinary NFA. Okay, so again, A will be the initial state and C will be the final state. Okay, so let's get all the path for our input. So let's consider A first. Okay, A. So epsilon closure of A, again, itself and the other state that it could reach through epsilon, which are B and C. So let's start with 0 input. If it's 0, it will just loop within itself in A. Okay, so, but A has an epsilon closure, wherein if it stopped with A, it could reach A, B, and C. So that's why ABC will be the final path or the final state or the next state rather when we stop with A. Okay, because it could be reached through epsilon. Okay, while in B, if it's 0, nowhere to go, so just leave it blank or dash. And at C, if it's 1, if it's 0 rather, it will just loop within itself. So C, and since there's no epsilon transition connected to C or going out of C, it will just be C, the finals, the next state. Okay, so let's move on with the B state. If it's 0, again, nowhere to go, but we all know that C is part of the closure of B. Okay, since we have an epsilon transition between B and C. Again, B closure is BC. So B, nowhere to go at 0. C at 0 will just stay within itself. Okay, If it's C state, if it's 0, will just stay within itself. Okay, now let's proceed with 1. So again, epsilon transition of A are A, B, C. If it's 1, based on this diagram, it will not, no, there's no path for 1 at A, so therefore dash. But if it's B, it will loop within itself, but B could reach both B and C, okay, through epsilon transition. So that's why the next path will be for B, final path for B will be BC, okay? And C at 1 will just loop within itself, so that's why CC. And for B, again, the B closure of B will be BC. So let's consider first state, which is B. If it's 1, will end with B, and B could reach, okay, both BC, okay? We have BC path, okay, for B. So that's why the final transition will be BC for B. And for C, it's just 1, so C is C. And state C, so same with the previous, it will just stay within itself. Okay, and then let's create this transition table for NFA. So A, so if it's 0 based on this table, it will go to A, B, C, and C. Okay, and B, nowhere to go. So we're going to union all this path, and C is part of ABC, so it will just be ABC here. So for A at 1, okay, no path, union with BC, union with C. C is part of C, and no path is just disregard it, okay? So the result will be BC, path, for A at 1. At B at 0, we have nowhere to go, union with C, therefore it's there, we have C, path, and then B at 1, so BC union with C, C is part of BC, so therefore B at 1 is just BC. And at C, so any value will just end with C state. Okay, so this will be the NFA transition. So we're not going to merge ABC, okay, to one state, but we're just going to, it will just indicate what are the possible path wherein A encounters 0, it will go to A, B, and C. That's the meaning of this ABC here. It will not be combined, but this will determine the path for A at 1, at 0 rather. Okay? And also in converting E Nfa to an NFA, so we need to determine the final state. So in the NFA final state from Nfa, so it will be any state that can reach the final state only by epsilon. Okay, can A reach C through epsilon? Yes, A epsilon epsilon C. B can reach C through this epsilon. So therefore, both A, B will now be, okay, a final state. So now let's draw the NFA. So we have 3 final state, A, B, C, and also A is the initial state. Okay, so if we have 0, it will go to B, C, or loop within itself. And if it's 1, we'll go to both B and C. So this will be the path for A, okay? And for B, okay? So if it's 1, it will just loop within itself. But if it's 0 or 1, it will go to C, okay? And when it's on C, it will just loop within itself. So this is the final NFA.